In this video, we begin to consider the need for questioning decision criteria numbers. Your models are sophisticated and your math is correct, but your answer is still probably going to be wrong. And if it's likely to be wrong, then you owe the people who are relying on it the truth. Now I can hear you thinking, everyone knows it's just an estimate based on the best available information we had at the time. We use this number until a better one comes along. That's the way the system works. Well, if this system never leads to bad decisions, mistakes, regrets, or unpleasant surprises, stay with it. But if risks could arise from a mistake, it may be better to anticipate them and manage them. If success depends on cost being accurate, however, you're going to want to question the number, $7,151,453. Every decision we make has at least one decision criterion, maybe more. Sometimes you'll know exactly what value that criterion will take in one decision versus another. Most of the time, that criterion will be uncertain.
For God's sakes, just give me the damn...
Thesaurus.com provides a powerful explanation for why people just want the number. Uncertainty evokes a lot of feelings that make us uncomfortable. Pause this video and look at some of these synonyms. When we are uncertain, we feel confusion, mistrust, skepticism, worry, hesitation, and indecision. No wonder people just want the number. Consider the cost estimate from before. With uncertainty accounted for, the truth looks more like this. The histogram on top shows the shape of the project cost data and provides insight into the range of possible values and their likelihoods. The cumulative distribution function on the bottom provides estimates of the likelihood of selected cost values being equaled or exceeded. The 5-number summary is a handy way to summarize selected numerical values that characterize the range of possible project costs. It does not display as much information as the distribution graphics, but it conveys a more honest picture than the number does. This analyst may speak for many when she says, "This is all great stuff, but until my boss can understand what I'm doing, at least on a macro level, it's almost a waste of time. He's not going to incorporate probabilistic information into his decisions because he doesn't understand it." This is one reason we will focus on numeracy in this module. Step 1 is to move decision makers off of their reliance on the number. Many businesses simply ignore uncertainty. If you do, the one thing you can bet on is that the number will be wrong. The question's not will it be off, but how far off will it be? The bigger problem with ignoring uncertainty is that once a value is generated and it enters the system, it becomes gospel. Nobody questions it anymore. It's in the system, written in stone. It's the official number, so it must be true. Or at the very least, it's the best estimate we have. We begin to believe the number we generated, forgetting how shaky the initial estimate may have been. It takes courage to stand up to a decision maker who's insisting on the number and to tell the truth. We do not know for sure, especially in a meeting where so many others are so ready to provide their numbers with the false bravado of certainty. Telling the truth about uncertainty may require you to brace against charges of incompetence or laziness from those who do not understand the pervasiveness of uncertainty. Uncertainty is practically inevitable for so many reasons, but incompetence need not be one of them. A product or project may have hundreds of individual parts, and the engineers and analysts working on those parts may be excellent at their jobs. Given the uncertainty in the world, an engineer or analyst who could achieve 95% certainty is doing a heck of a job. but it only takes a few sub-spec elements to make the entire product or project sub-spec. We may be justified in having a high degree of confidence in our cost estimate, for example, and we may believe that any individual quantity or unit price will turn out as expected. But when we take the hundreds of components together, the probability of the cost equaling the sum of these most likely values can be vanishingly small. Each expert gives us an honest and accurate most likely result. If we sum up the most likely results, we forecast a precise cost. The problem is we will not get the most likely value for each component. We are bound to get a few unlikely results despite the competence of our staff. And those differences can sometimes make all the difference between a good decision and a failed decision. The reason for questioning the numbers is so that decisions can be based on the truth. And when the reason for questioning the numbers is so that decision makers need to understand that we are uncertain. And when the truth is we are uncertain, why we are uncertain. Decision makers need to understand that we are uncertain. Any options we have, why we are uncertain, reducing uncertainty, how uncertain